In number 1, we're taking the derivative of y equals 7 to the x, and we're just doing this according to our formula for taking the derivative of exponential functions. So we have dy dx is equal to log 7, or ln 7, times 7 to the x. In number 2, we're going to use the chain rule. All right, so we have dy dx is equal to, again, ln 7 pops out, times 7 to the cosine x, times the derivative of cosine x, which is minus sine x. All right, so that's chain rule. In number 3, we have a product. Here's our first function is x squared, and our second is 5 to the x. So we'll use the product rule. All right, so the derivative is equal to the first function, that's x squared, times the derivative of the second. Derivative of 5x is ln 5 times 5x, plus the derivative of the first function, that's 2x, times the second function, times 5 to the x. All right, in number 4, we're taking the derivative of log base 5 of x. All right, we know that a 1 over ln 5 pops out, times 1 over x. In number 5, we're going to use a chain rule. All right, so we have dy dx is equal to the derivative of log base 7 of u. All right, so that would be 1 over ln 7 pops out. And here we have 1 over the inside, 1 over u, in this case 1 over 5x cubed plus 4. And now we have to multiply by the derivative of 5x cubed plus 4. So that's 15x squared. So I'll put that in the numerator. In number 6, we're going to use log differentiation, because if we had a log in front of this expression, then it would expand and it would be easier to take the derivative. So this is a good function for log differentiation. So first we take the ln of both sides. And then we take advantage of the log properties and expand. So we'll bring down the 10, so that would be 10 ln 7x to the 4th plus 1, minus, this is in the denominator, so that's minus, bring down the 1/2, okay, because we have that square root, which is exponent 1/2, 1/2 ln 3x plus 2. Okay, so this is expanded. Now it's easier to take the derivative now that we've expanded the right-hand side. The derivative of ln y is 1 over y times the derivative of y, so that's y prime over y. And on the right, we have 10, derivative of this ln expression, put this in the denominator, and multiply by the derivative of 7x to the 4th plus 1, so that's 28x cubed. We'll put that here. Okay, now the derivative of this ln, put the 3x plus 2 in the denominator, and the derivative of 3x plus 2 is 3. And now we just multiply both sides by y. Okay, so let me just, in brackets, copy this side over. I'm going to put the y right here. But instead of writing y, I'm going to go straight to what y is equal to, this expression. So let me put that here. 7x to the 4th plus 1 to the 10th over square root of 3x plus 2. Okay, so that's because we multiply both sides by y, so we have a y right here. And I'll just substitute what y is equal to. And now let me fill in with this in the brackets. So here we have multiplying by 10, 280x cubed over 7x to the fourth plus 1. And now I'll multiply through by the 2 in the denominator, so we have 6x plus 4. All right, now we're using log differentiation to differentiate this equation, and here we have x in the base and x in the exponent. So in this case, we don't have any other method other than log differentiation. All right, so let's log both sides, and we're doing that so that this 2x plus 1 comes down in front. All right, let's bring this down in front. Just using the log property. Okay, now we're ready to differentiate both sides. On the left, we get y prime over y. On the right, we're going to do a product rule. This is the first function, this is the second. So we have the first times the derivative of the second, put the 5x plus 1 in the denominator, multiplied by the derivative of 5x plus 1. Now the derivative of the first, that's 2, times the second. All right, now the last step in log differentiation is always multiplying both sides by y. So we get y prime is equal to, and here I have y on the right-hand side. I'm going to write what y is equals to. So I'm going to write 5x plus 1 to the 2x plus 1 times all this sum. All right, let me multiply 5 times 2x plus 1. So we have 10x plus 5 over 5x plus 1 plus 2 times ln 5x plus 1.